Foundations of Math 30. So what we're talking about, we're kind of integrating things that we've learned before, right? So for this one, we're talking about probability, and that's the fundamental thing, and the tricky part is going to be this right here. What are the favorable outcomes? So we're going to have to piece a few things together here to try and determine what the favorable outcomes are for each situation, because it's going to be maybe a little tricky. So if we take a look at this investigate the math, it says this: a volunteer activity, 10 students want to put on a talent show at a retirement home. To organize the show, 3 of the students will be chosen at random to form a committee. Okay, doesn't say anything about order, just says 3 random students. Victoria really wants to be on the committee since her grandmother lives at the home. Each student's name will be written on a slip of paper placed in a hat. Then the 3 names will be drawn. So A says, is Victoria's name just as likely to be drawn as any other name? Well, yes, there's no preference for her. Doesn't have her name in the hat more than once. So the answer to that one is yes. B says, does the order in which the names are drawn matter? And so because we're just talking about 3 random students, right, chosen at random, then the position that they are drawn wouldn't matter. So no, it doesn't matter. This is going to lead us to combinations probably, right? So the next one says, in how many different ways can 3 names be drawn from the hat with 10 names? Okay, so we have 10 names and we want to choose 3. That's where we get this from. So that is 120 names. Okay, so that's the total number of ways. If we were stopping there, there's 120 ways that 3 names could be chosen out of 10. But this one's about Victoria, and she really wants to be on there. So in how many different ways can Victoria's name be drawn with 2 other names? So in this group of 3, 1 is already Victoria, and the other one, there would be 2 more kids there. So if Victoria's name is in there, how many different ways can these 2 names be organized, right? So if there was 10 without Victoria, it's 9. So we have Victoria, that's 1 Victoria, times 9 choose 2. So we actually have 36 names that have her, the 36 ways that 3 students can be chosen, with her being one of them. So then what is the probability that Victoria's name will be drawn? Okay, so what we have to do here is take into account how many groups of 3 have Victoria in them, and that's what we found out in D. So the total, I guess, would be just 10 choose 3, right? That's the total. And then this is the number that has Victoria in it. So we have 36 out of 120, or exactly 30%. Okay, so did you try the reflecting questions? Did you say you had trouble with the reflecting questions? Okay, so you kind of got your, yeah, go ahead. Okay. Yeah, we don't have to go over the reflecting questions really, but what we do need to understand is that the favorable outcomes, you might have to use permutations and you might have to use combinations, right, for these ones. So here's one here, example 1, if we want to go through this one real quick. It says Jamal, Ethan, and Alberto are competing with 7 other boys to be on their school's cross-country team. All the boys have an equal chance of winning the trial race. Determine the probability that Jamal, Ethan, and Alberto will place 1st, 2nd, and 3rd in any order. Okay, so this one looks like, now it actually is a bit tricky here when it says Jamal, Ethan, and Alberto placing 1st in any order. So is that combination or is that permutation? Okay, if it says in any order, that means the order doesn't matter, right? So that looks like it's going to be combination. Yes, I would agree with you. Okay. All right. So if we have 3 students here that we're talking about, and no, let's use the combination. Right. We can't actually do it with permutations. We can, but let's do the combination method. So if we have 3 choose 3, right? What's that going to be? That's actually going to be 1. When you have this number and this number being the same, it's always just 1. Okay, And we have, it says there's 7 other boys. So that's 10 boys in total. So we have 10, and 3 have to be chosen, right? So there's a total of 120 that could be chosen. Okay? So if we want to take a look at the chance that these boys are the group of 3, so there's only one chance out of a total of 120 chances. So the probability that we have Jamal, Ethan, and Alberto is 1 out of 120, or about approximately 0.83%. Okay? Yeah, so like I say, there is a way to do it with permutations, but it's a few extra steps, so combinations would definitely be the way to go. Alright. Now example 2, I don't know if we want to go over example 2 or not, but I will point this out. Okay, I'm going to leave this up on the screen so that you can, if you want, you can go over this. It says determine the probability that at least one of Blake's children is a boy. Now I haven't read the whole example. You can read that on your own if you want and take a look at what I've done so far. But at least one is a boy. That means that we could have 1 boy, or 2 boys, or 3 boys, right? And if you think about that, you could take 3 different cases there and add them up if you want, but an easier way to attack this problem is to say that at least 1 boy, the probability of at least 1 boy, is the complement of the probability that all of them are girls. And so if you can, instead of adding up a bunch of different cases, if you know that there's just 1 case that is not included, you can take the total and subtract just the number of the cases that just that 1 case. Do you know what I mean? So in this case, at least 1 boy means 1 boy or 2 boys or all 3 boys. And why don't you just take the total number of possibilities that you have and subtract the 1 possibility that they are all girls. And so that's just kind of a tip, you know, for solving this kind of problem. So sometimes you want to take the total and minus, you know, something, just the 1 thing that you don't need. Okay. So again, this is example 2. It's in the textbook, so I'll get you to go ahead and look at that. So that is example 2 is right here, and it's a better explanation than I could give you in the few minutes we have. So you can look at example 2 there. But I think that what they do, yeah, so they do this here, you see. The probability of at least 1 boy would be 1 minus the probability that they're all girls. And so that's just a little bit of a tip there. Yep, that's right. It would work the other way too. So if you had, yeah, so here we go, you see, you could have 1 boy, you can have 2 boys, you can have 3 boys. So if you add up basically all of those, then yeah, there would be 3 ways you could do it, 3 ways, and then 1 more way. So that's 7 ways that you could have 1 boy, or 2 boys, or 3 boys. So yeah, you can add up as well. Okay, so yeah, just as far as the notes here, I guess I just have some other examples, which there are examples in the textbook too. Is this the example 4? Yeah, 18 bikes. Okay. Let's just see here. Okay, I'm just about at 10 minutes here for this lesson. This one is in the textbook as well, so if you want to look at example 4, this is example 4 in the textbook. Okay, so I'll let you take a look through that, and if you have any questions about this, again, it's probability, it's favorable outcomes. So the big important thing is finding out what goes on top there, the favorable outcomes, and then divide by the total number of outcomes. Okay, so it's all stuff we've learned before, just kind of putting it together. So maybe what I'll do is I'll get you to try some of the questions, and some of them you kind of have to think outside the box. But if you have any problems, you can maybe check back in with me, and I'll help you with the problems from the assignment. few more, just a bit more time, a couple more examples here. I'll just walk you through example 2. That is the example 4 in the textbook. So if you've had a chance to give it a try, then let's just check and see how you did here, see how it compares to what I have here. So again, just the question says there's 18 bikes, there's 3 rows, 6 friends are reserving bikes, and A says, what are the odds that they will be in a row together? Okay, what are the odds that they will be in a row together? Well, there's 3 rows, so the 6 of them could be in row 1, row 2, or row 3, if you keep that in mind. Now, the number of the ways that the 6 friends can be arranged in the line is 6 factorial, okay, because order would matter because it's an arrangement. The number of ways that the rest of the class could be arranged is 12 factorial, okay. The total outcomes would be 18 bikes because there are 18 people, 3 rows of 6. So if we look at what we have here, here's the 6 friends, the ways that they could be arranged. Here are the 12 other people and the ways that they could be arranged as well. And then there's 3 rows. So this could happen 3 different ways, right? So if you look over to the right here, you could have a row of the friends on the top, and then the other 12 on the well, I say top, but the first row, and then the second, third could be others, right? We could have the friends could be in the middle, and the friends could also be on the third row. So that's 3 different options for each of these arrangements. Now it does say what are the odds, which strikes me as funny here. Where's my textbook here? Here. So let's get back. Let's take a look at that example. So what are the odds? It still does give us a probability, I guess, doesn't it? Yeah. Determine the probability. So maybe that question that was framed here. What are the odds? What's the probability? I think that's the actual question. Apologize for that. So what's the probability? All right. And what happens if Allison and Franco need to be on the ends? Okay. Allison and Franco on the ends. Well, there are 3 rows still, but Allison and Franco, if they're on the ends already, that means that we have 2 end spaces already taken up, and then we have the other friends in the middle. So there's 2 chances for whoever wants to be in the first, and then 1, the leftover person goes there. Then this is 4 factorial, that's the other 4 friends. They can be arranged in any way. Again, the rest of the group is 12 factorial, right? And it looks like each of these friends could still be in each of the 3 rows. So that's where we have here. We have the 2 friends on the ends, the 4 friends in the middle, the 12 other people, and then each of the 3 rows. So you have that's your percentage there. Now, I did say that this was example 4. Yeah, looks like it is. All right. There's another way to look at it there. Okay, so here's the key ideas. Again, take a look at this. Fundamental counting principle. You may have to use techniques involving permutations or combinations to solve the probability problem. So remember, favorable outcomes divided by all total possible outcomes times 100%. That's your probability. Okay, and do as many of these questions as you can. If you're in my class, you can check on Google Classroom for the specific questions that you need to have done.